You thought we were done with that? No, we weren't. Have you memorized your multiplication tables? I hope you have at least partially. At least partially. Now memorize your multiplication tables. Anyhow, we're starting with multiplication with the threes. So there's many different ways to find answers for multiplication problems, including counting on a number line, skip counting, actually remembering your multiplication table, and a whole lot of different other, strategies. But for the sake of yourself, your teacher's sanity, and everybody around you, please remember your multiplication table. It will only help you. Even if you don't decide to take math after it's not mandatory, which I know in some countries it's mandatory for all 4 years. Some countries it's mandatory for only a few. But even if you're not deciding to take math as a major, or in college, university, whatever program you end up going into, you're probably going to have math somewhere. Psst. One of my math teachers, her daughter was an artist, except she was a sculptor, so then she had to do mathematical calculations for hanging her artworks. Yeah, math is important, kids. And multiplication is one of the most commonly used things in math. It makes things a whole lot speedier because it's like addition, except repeated many times. But of course, we went over that last time, so I'm going to move on with multiplying by 3. So here is a part of the multiplication table with the 3's. Kindly list it out for you. Now remember to remember your multiplication table. Anyhow, find 3 times 7. It's on the multiplication table. 3 times 7 equals to 21. Now what about 3 groups of 4? 3 groups of 4 is basically 3 times 4. And 3 times 4 is also on, this bar of multiplication that we gave you. 3 times 4 is 12. 2 groups of 3, that's 2 times 3. And 2 times 3 is the same as, 3 times 2 because commutative property. And 3 times 2 is 6. 3 times 1, identity property. Anything times 1 equals to itself. 3. 5 times 3, just look at the multiplication table. Or better yet, remember the multiplication table so you don't actually need to look at it. It's just in your brain. 15. 9 groups of 3, 9 times 3, 3 times 9, same difference, 27. 6 times 3, 3 times 6, 18. 3 groups of 8, 3 times 8, 24. 3 groups of 3, 9. 3 times 3 equals to 9. Now, really, the trick to multiplication is that, there really isn't any trick, because you just have to remember your multiplication table. If you want to be remotely successful and pass grade 9 or 10 and not drop out of high school, guess what? You're going to have to remember your multiplication table. You have to remember it. Memorize your multiplication table. We move on to multiplication of 6. This is the 6th part of the multiplication table, or the times table. Now you can double multiplication facts, but it's not recommended. For example, you can say, 6 times 3 is like 3 times 3 plus 3 times 3. But honestly, if it's on the multiplication table, you should remember it. Because if you don't remember your multiplication table, everything's just gonna, you're just gonna Seems going to be, seems gonna go not good in the future. But of course, if you want to double multiplication facts, use these for large numbers. Such as, say, let's see, 15 times 30. After a few years of doing multiplication, you know that 15 times 15 . So this is equal to 225 plus 225, which is then equal to 450. Yeah, this is when doubling facts can be used without, well, if you use doubling multiplication facts for large numbers, then okay, sure. But if you use them for numbers that are on the multiplication table, you're not going to survive grade 9, much less grade 10 or 11. And it only gets harder. So write a multiplication sentence for each picture. Well, we have 1, 2, 3, 4, 5, 6, and then 1, 2. So that's 2 by 6, which is 2 times 6. Or 6 times 2. Both of these work. Equals to 12. Here we have 1, 2, 3, 4, 5, 6. And then 1, 2, 3. So 6 by 3 or 3 by 6. That's 18. How do I know this so quickly? Because I memorized my multiplication table. Here it's 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. So that's 6 by 5 or 5 by 6, which is 6 times 5 or 5 times 6, which is 30. Now, we're going to explore the other bits of, well, the multiplication table part that is labeled with 6. 6 times 9. 6 times 9, if you remember your multiplication table, is 54. 6 times 4. Okay. This is equal to 24, because then again, 24 is just one of those numbers that has plenty of factors. Too many factors. Ugh. 24 flashbacks. Anyhow, 6 times 4 is 24. 6 times 2, 6, 12. Besides, 6 times 2 is up there already. 6 times 6, 36. Again, one of those special numbers that you just end up remembering. But then again, you have to remember everything on the multiplication table. At least everything that's 9 or below. I don't care if your multiplication table has 10, 11, and 12. You could choose not to remember those, but you have to remember 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't actually need to remember 1, since remember, guys, we learned this last chapter. Anything times 1 is equal to, well, that thing. Now, 6 times 7, multiplication table, 42. 6 times 1, identity property, 6. Okay, so let's take a break from the multiplication. I know we only got 2 sections of it so far, but we're still taking a break and moving on to a problem-solving strategy. This problem-solving strategy is often used for algebra. So the reason why, well, we call it patterning in algebra. Look for a pattern. Erin was making icing. In her first bowl of icing, she added 5 drops of red food coloring. The second bowl had 10 drops. The third bowl had 20. If she keeps the pattern up, how many drops are in the fourth bowl? Well, what do we know? We know how many drops each bowl has. And what do we need to find out? Well, we need to find out how many drops are in the next bowl. Now we're going to look for a pattern, because that's the strategy that we're supposed to use. When you're looking for a pattern, it usually does help to make a table. So, bowl and drops. First bowl, second bowl, third bowl, fourth bowl. Drops, 5 drops, 10 drops, 20 drops. Now, when you're looking for a pattern, you have to look at both. Because you know that there's two types of patterns. One where it's input-output. The other one where it's just there's less of a relationship between the input and the output. So here we have 1 and 5. It could be 1 times 5 or 1 plus 4. That could be the pattern rule. So we move on to the next one. 2 and 10. 2 plus 4 is not equal to 10. So that's not the pattern rule, but 2 times 5 is equal to 10. 3 times 5 is not equal to 20. Therefore, it's less of an input-output thing here. Now here, we look only at the drops. 5, 10, 20. It seems like it is multiplying by 2. So technically, the fourth bowl would have 20 times 2, which is like 2 times 10 times 2, which is 40 drops. Okay, that's a lot of food coloring. 40 drops of food coloring. However, if you go with a different approach, you could have plus 5, plus 10, plus 15, which would give us 35 drops. So when the pattern isn't exactly the most clear, then you give 2 answers. So it may be 40 drops of food coloring, or 35 drops. Sometimes this happens in patterning. Usually that's why there is more terms or more points that we get to help us define the pattern. We go back, we look at our answer, does it make sense and why? I mean, it makes mathematical sense because the relationship is either times 2 or plus 5 plus 10 plus 15, so on. Both of these would work. We look back at the question to see if our information is correct, and we get first bowl 5 drops, second bowl 10 drops, third bowl 20, keeps the pattern up, how many drops in the fourth bowl? Therefore, our answer should be completely fine. Of course, nobody actually puts 40 drops of food coloring into one bowl of icing unless it's a ginormous bowl. But then again, math, I've told you this before, and I will tell you it again. In math, reasonableness isn't so much logical reasonableness. It's more mathematical reasonableness. Anyhow, moving on. Multiplication in the 7th. Now, here's the thing. You can add on to a known fact to find a new fact, but this is multiplication that's on your multiplication table. If it's something like, say, let's see, 13 times 4. You could do, say, 7 times 4 plus 6 times 4. You could do that because 13 is annoying. And if you do that without, well, seeing as if it's 13 times 4, then it's also not that hard. It's just 52. Here's the thing, I don't know why you would want to do this, especially if it's something within your multiplication table. Because if you have to do this for something in your multiplication table, you're not going to survive high school. Or you're going to barely scrape through high school. Because your calculator might run out of battery. And you can't depend on calculators for everything because your calculator depends on how good your calculator is, but some calculators, you'll mess up your order of operations. Now that's something you're learning further ahead, but order of operations are very important. So messing them up is not something you want to do. Now just remember your multiplication table, for goodness sakes! Anyhow, here's an example of adding on to a known fact, such as 7 times 4, and then you know that 5 times 4 is 20, and 2 times 4 is 8, so that's 20 plus 8, which is 28. But you could just remember your multiplication table. Here's the 7th bit of the multiplication table. Kindly copied it out for ya. Now we're going to do some, well, multiplication sentence identification. I guess you could call it that. Anyhow, write a multiplication sentence for the picture, or, well, each picture, technically. We have 1, 2, 3, 4, 5, 6, 7. So that's 7 times 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 times 9. That's 63, by the way. Here, it's 1, 2, 3, 4, 5, 6, 7. 7 times 1, 2, 3, 4. 7 times 4, which is 28. Technically, you don't actually really need this bit because the multiplication sentence is technically just this part. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 times 7, 49. I remembered my multiplication table, see? Remember your multiplication table makes multiplication a lot quicker. Now, find each product. 6 times 7. Remember your multiplication table, children. 42. 3 times 7. Remember your multiplication table, children. 21. If you really want to skip count, it's 7, 14, 21, or... I mean, you could go the long way, but that'd be annoying. So it'd be 3, 6, 9, 12, 15, 18, 21. So yeah, don't go the long way. Just remember your multiplication table. 2 times 7, 14. 5 times 7, 35. Again, multiplication. As long as you understand what multiplication is, you don't actually need that many tricks. You just need to know the rules and remember your multiplication table. 7 times 1, identity property, 7. 7 times 8, 56. Moving on, multiplication in the eights. Find 3 times 8. 3 groups of 8 is this, which is 24. 8 groups of 3 is this, which is also 24. 3 times 8 equals to 8 times 3 equals to 24. Commutative property, children. Commutative property. Yeah. Now moving on to the practice problems, and there's the 8 part of the multiplication table. Write a multiplication sentence for each picture. Let's do some counting. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3, 4, 5, 6. 6. 8 times 6 is 48, according to the multiplication table, which you should memorize. Again, 1, 2, 3, 4, 5, 6, 7, 8. 8. 1 times 1 is 8, because of the identity property of multiplication. Now multiply. 0 times 8. 0 property. 0 times anything is 0. 9 times 8, multiplication table, 72. 8 times 5, multiplication table, 40. 8 times 7, multiplication table, 56. 8 times 2, multiplication table, 16. And 8 times 1, well, we already have that, 8. Now we move on. Wow, who would have guessed that the next section was multiplication by 9? Okay, for 9, there actually is a trick. It's 1 times 9, you put down your first finger, and it's 0, 9. 2 times 9, you put down your second finger, 1, 8, 18. 3 times 9, 2, 7, 27. 4 times 9, 3, 6, 36. 5 times 9, 4, 5, 45. 6 times 9, 5, 4, 54. 7 times 9, 6, 3, 63. 8 times 9, 7, 2, 72. 9 times 9, 8, 8, 1, 81. And 10 times 9, 9, 0, 90. Yeah, I came across that trick a long time ago. It's a very interesting trick, but then again, you could just remember your multiplication table. Now over there you can see 9 times 8, it's 8 groups of 9, and it's also 9 groups of 8, and it's equal to 72. And what do we get? A. Multiply. Really, for this, you just need to remember your multiplication table. 9 times 5, 45. 9 times 7, 63. 1 times 9, 9. 9 times 3, 27. 9 times 2, 18. 9 times 9, 81. 9 times 6, 54. 4 times 9, which is also 9 times 4, is over here, 36. 9 times 0, 0 property, 0. Really, you just need to remember your multiplication table and the general rules of multiplication. There are a few strategies that are useful, but to be honest, you have to remember your multiplication table either way if you want to be successful in math. Moving on to some problem solving. Choose a strategy. Tony likes candy. I mean, most people do like candy. On the first day of summer break, he ate 2 pieces of candy. On the second day, he ate 4. On the third day, he ate 6. If this pattern continues, how many candies will he eat on the 10th day? So what facts do we know? We know that the pattern continues, first of all. We know how many pieces of candy he eats on each of the first 3 days. And what do we need to find? How many candies will he eat on the 10th day? For things like this, you look for a pattern, and usually when you're looking for a pattern, you would make a table. Or you do it in your head. But if you want to show your work, usually you would do it in table form. So day, and then number. Yes, guys, the hashtag sign is a number. This is also called the pound key on your phone, or your family's phone. Usually when you're checking your voicemail on a mobile phone, they will ask you to enter your access code and then press pound. This is a pound key, guys. So first day 2, second day 4, third day 6. Then we have day 4, day 5, day 6, 7, 8, 9, 10. We realize 1 times 2 is 2. 1 plus 1 is also 2. 2 plus 1 is 3, which is not equal to 4. 2 times 2 is equal to 4. 3 times 2 is 6. It appears that the pattern rule is day times 2, or day number times 2. So on the 10th day, it would be 10 times 2, which is 20. If you really want to write down the entire thing, well, this is what it looked like. But he will eat 20 candies on the 10th day. Is the solution reasonable? Reread the problem, and how can we check our answer? Well, for patterning, checking your answer really is just redoing the problem and making sure that you didn't mess up and that your pattern rule makes sense, which, well, it does. And since by reasonable it means mathematically reasonable, it does. Now we reread the problem to make sure that we actually did get our information correct. Tony likes candy. On the first day of summer break, he ate 2 pieces of candy. On the second day, he ate 4. On the third day, he ate 6. If this pattern continues, how many candies will he eat on the 10th day? Okay. Our information was correct. Our calculations were correct. Therefore, our answer should be correct. Unless your teacher's pulling a massive prank on your entire class. Moving on to some algebra. And what would multiplication be without properties? Well, you can use the multiplication property or properties of multiplication to multiply 3 numbers. Find 4 times 3 times 2. So for the commutative property of multiplication, you could do 4 times 3 times 2, 4 times 2 times 3, 3 times 2 times 4, 3 times 4 times 2, 2 times 3 times 4, 2 times 4 times 3. So here you get 4 times 3 is 12. 12 times 2. You guys didn't really learn 12 yet, so you can't really use this one. You also can't use 3 times 4 times 2 because that would still be 12 times 2, which also you guys didn't learn yet. So you could have 4 times 2, which is 8, times 3, and then 8 times 3 is 3 times 8, which is 24. 3 times 2 times 4, 3 times 2 is 6, 6 times 4 is 24. 2 times 3 times 4 is, well, still 6 times 4, which is still 24. And 2 times 4 times 3 is still 8 times 3, which is still 24. You can also use the associative property of multiplication, and you end up with stuff like this. Now, the order of operations dictates that you have to do the stuff in brackets first. Basically, the associative property of multiplication says that, well, it doesn't really matter what you put in those brackets if it's a long chain of multiplication. So essentially, it's telling you that you could group multiply things together. Now over here, it's not that obvious because you could do it easily with commutative property. Technically, if it was a long chain of multiplication and you needed to group, then you could use the commutative property. But then again, if you're multiplying just 3 numbers, it doesn't really matter which one you use. But if you're multiplying a long chain, that's when you really want to use associative property. So this would be 3 times 2 is 6, so that's just 24. Yeah. This is another way of grouping. Now let's do some practice problems. Find each product. 7 times 1 times 2. Well, if there's a 1 in it, then you could just ignore the 1 because it's not going to make a difference anyways. You get 7 times 2, which is 14. 3 times 3 times 5. 3 times 3 is 9. 9 times 5 is 45. 4 times 2 times 4. 4 times 2 is 8. And then 8 times 4 is 32. Here, you see that there's a 0. If there's a 0, the entire thing becomes 0. If there's 1 0 in a long chain of multiplication, it's just 0. You don't need to bother. 2 times 5 times 3. Well, 2 times 5 is 10. And you know that 10 times 3 is 30 because you've learned multiplication by 10. But you could also do it this way. 2 times 3 times 5. 2 times 3 is 6, and then 6 times 5 is 30. You get the same answer, except you don't have to deal with anything above 9. 8 times 3 times 2. Well, 8 times 3 is 24, and you haven't really learned how to deal with that yet. So, associative property, you could do this. And you end up with 8 times 3 times 2 is 6. 8 times 6 is 48. Which you guys, well, multiplication table, kids. 0 times 3 times 4, again, there's a 0. The entire thing's just 0. 2 times 2 times 2. That's 4 times 2, which is 8. Oh yeah, by the way, these are also a type of special thing that you end up learning in grades 5 and 6. 3 times 2 times 3. Well, 3 times 2 is 6, times 3 is just 18. If you want to switch it around and you end up with 3 times 3 times 2, that's just 9 times 2, which is still 18. Find each missing number. 5 times 6 times something equals to 60. So we know that 60 is 6 times 10. So you could take off, well, actually, let's write it down first. Times 10. So you could take off the 6 from both sides. And you end up with 5 times something equals to 10. Last time I checked, 5 times 2 equals to 10. And if you want to check it over, then you get 5 times 2, 10, 10 times 6, 60. Remember guys, it's a long chain of multiplication. You could group it however you want. Now, something times 2 times 3 equals to 24. 2 times 3 is equal to 6. Something times 6 equals to 24. And last time I checked, 4 times 6 equals to 24. If you want to check this over, 4 times 2, 8, 8 times 3, 24. 3 times 3 times 3, that's 9 times 3, which is equal to 27. Over here, it's something times 4 times 2 equals to 72. 4 times 2 is 8. And then, last time I checked, 9 times 8 equals to 72. Now that's that section done, find a rule. This is a patterning thing. A rule tells you what to do. This works in math, too. Oh, that rhymed. Anyhow, to make a tissue box guitar, oh gosh, these things were, I don't know if you guys still play with these, but we did. So basically, we got a tissue box, and we put elastics on it, and we poked the elastics. Yeah. Pretended we were actually using a guitar. Some of them actually tape a paper roll to one end to make it actually look like a guitar, or more of a ukulele, but hey, we still call them tissue box guitars. Sue needs an empty tissue box, a paper roll, and 3 elastic bands. How many of each thing would she need to build 4 tissue box guitars? Find a pattern. Well, here it's just, for tissue boxes, it's just +1. Tissue box. For paper rolls, it's still just +1 since there's, well, 1 paper roll each. And for elastic bands, EB, it's +3 for each. So that's the pattern. Now we extend the pattern. Okay guys, but seriously though. Technically, if she wants 4 of them, then it's 1 + 1 + 1 + 1, which is multiplication, kids, 4 times 1. So that's 4 tissue boxes. And then 4 times 1 again for paper rolls. And then 3 + 3 + 3 + 3, which is 4 times 3 for elastic bands. And 4 times 3 equals to 12. 12 elastic bands. We move on to some practice problems. Francine goes to a sale to buy chocolate bars for her class. How nice. At the sale, she could get a free bar of chocolate when she buys 3 bars. How many free chocolate bars can she get if she buys 18 chocolate bars? Well, how many 3's are in 18? 3 times 6 equals to 18. So this is less of a finding a pattern thing than, well, division, which we will be learning about in the next chapter. Now that's 3 times 6 equals to 18. So technically, since it's for every 3, she gets 1. Then it's, well, 1 times 6 is the amount that she will get free. So she'll get another 6 free chocolate bars. 6. I recommend that you answer in full sentences though, because some teachers are particular about it. Write the rule for each table, then complete the table. So here you have input 5, output 5. Well, that's equal. And 9 and 9 is also equal. 11 and 11 are also equal. So rule I equals to O. Usually you wouldn't use I and O in math. It would be X and Y. So if the output, Y, was 7, and, well, the input and the output were equal, then what's the input? 7. Here we have input, output 9, 18. Well, that could be 9 times 2 equals to 18, or it could be 9 plus 9 equals to 18. 11 and 20. 11 times 2 is not equal to 20, but 11 plus 9 equals to 20. So the rule is plus 9. 15 plus 9 is well, technically we should put x for input, plus 9 equals to y. 15 plus 9 is 24. But what if the output was 34? Then what do we do? Well, we balance the equation, and remember what we talked about with addition, expressions, and equations? Well, use subtraction. So 34 minus 9 is 25. That's that one completed. Now we move on to the last question of the section, but it's not time to slack off yet. 6, 24. So 6, it's either plus 18 or times 4. Now we look for another input-output pair that is complete, which is 9 and 36. Last time I checked, 9 plus 18 is not 36. It's 27, by the way. But 9 times 4 is equal to 36. So the rule is times 4. X times 4 equals to y. Now output, over here, it's y, which is 28 for this one. Something times 4 equals to 28. 7 times 4 equals to 28. That's the input done. Now to find the output for the input of 8, we just plug the input in. 8 times 4 equals to 32. And that's the output. Well, that was chapter 5, kids. See you next chapter.